Hi, in this video we are going to implement the Knapsack problem together, so let's get started. I'm going to create a new class, a new project for the Knapsack problem, and I'm going to create a class, for example, Knapsack. Default package will be okay, and class application. So in the Knapsack we are going to have a few fields variable, for example private int number of items. We are going to have a private int capacity of Knapsack. We are going to have a private array of integers, the weight of items. We are going to have a private integer, the profit of the items. It is the weight of the items, it is the W's, the profit of the items. I think we have denoted with V. Yeah, although it is not too consistent because we are going to denote the running index with W, whatever. So I'm going to decomment it in order to avoid confusion. So we are going to have a private integer total benefit. It's going to be the cost we can make after solving the items we have managed to take with the help of the Knapsack. And of course we have a private two-dimensional array, the items taken, for example. It's going to have 0 or 1. If we take an item, it is 1. If we do not take it, it is 0. So I'm going to have a constructor with I think number of items. It's okay. I'm going to have a capacity of Knapsack. I'm going to have a weight of items, and I think I'm going to have a profit of items. Okay, so like that. Okay, so I'm going to have a public void solve problem method. I'm going to define a two-dimensional integer array. It's going to be the Knapsack table. And I'm going to instantiate it. It's going to have as many rows as the number of integers, plus 1 because we have to store the 0, and as many columns as the capacity of Knapsack. Okay, and of course I'm going to initialize the items taken. It's also going to have a number of items plus 1 and the capacity of Knapsack plus 1. Okay, so we have to iterate through the whole table, so we are not going to we can't make it without iterating through the table. It is integer n, the I, because I denoted the index of the rows with I in the theoretical video. We start with 1. We can start with 1 because the first row and the first column with the 0 indexes has all the elements 0. We can iterate through and set it to 0, but I think Java automatically initialize it with 0, so we can start with the 1. I less than or equal to this, that num of items, I plus plus, and as I said earlier, we are going to have an inner for loop integer w equals to 1, w less than or equal to this, that capacity of the knapsack w plus plus. Okay, so first of all, if we not take the item with index e or item with index I, as we said earlier, we just have the knapsack I minus 1 and w. Else we have to declare take item equals to 0, because we have to check whether the weight of items I is less than or equal to the v, because if not, as we remember, we wanted to leave it as 0. So the take item is equal to, unless, because if we are not checking it, the index may be -2, and the -2, I think we would get a runtime exception, so we have to do it. So profit of the items with I plus knapsack table I minus 1 and the v minus the weight of the items with the index I. Okay, v minus 1 was the problem. Oh, it's an I. First of all, it's an I. Yeah, because it's a two-dimensional items taken. Total benefit, okay. Knapsack profit I, and the knapsack of I minus 1, v minus weight of items I. Knapsack table plus undefined for the argument type as, and with the profit of items I. I'm going to look for the problem and yeah, I'm not detected, although I take a look at the profit of items and I set it to a two-dimensional array by mistake. No, the profit of items is a one-dimensional array. Okay, so this is good. And of course we have to calculate, we have to set the knapsack table with the given indices, the mass, that max, this is the so-called magic formula. So not taking item and take the item. And if the take item is greater than the not take item, it means that we take the items, so we have to set the items taken with index I and W to 1, which means that we take item with index I. Okay, and else, of course, we have to say that items taken I W with W is equal to 0, which means we do not take item index I with index I. And in the end we have to set because the solution for the problem is the last element, so after the for loops we have to set the total benefit is equal to the knapsack table, the number of items, because it's going to be the last item, I mean on the last row and on the last column. So it is the, I think, capacity of knapsack, yes. So That's all, and I'm going to implement the print with show result method, public void show result. I'm going to first of all show that the total benefit is equal to this dot total benefit. And I'm going to iterate through the integers n equals to this dot num of items. We just have to v equals to this dot capacity of the knapsack, and as far as n is larger than 0, n minus minus. Okay, and we just have to check whether the this that items taken and maybe it would be consistent to use i's. Okay, we used I so far, so why to change it for n? But okay, I and v is equal to 1. It means that we have taken that item. So we iterate through the table and check whether it is a 1 or a 0. And if we 1, we say that we have taken item number plus I. And of course we have to recalculate the weight. So this that weight of items I. Okay, Control Shift F to auto format a bit, and I think it's going to be okay. So let me check it. I'm going to have an integer num of items equals to 3. I have a int capacity of knapsack is equals to 5. I'm going to have an integer weight of items is equal to new integer num of items plus 1, num of items plus 1, the capacity of the knapsack plus 1. And yeah, because of like this, we have to get rid of this. And the weight of items equals to 4. 2 is equal to 2. With the 3, it is equal to 3. I'm going to create a integer array for the profits. Profit of items equals to new integer. It is the num of items plus 1. Profit of items 1 is equal to 10. I'm going to copy and paste. It's going to be 4. It is the example we have watched in the theoretical video. I'm going to create a knapsack class. Knapsack equals to new knapsack. Num of items, capacity of knapsack, weight of items, and profit of the items. Okay. So we are going to run our knapsack dot solve the problem and knapsack dot show results, and we came to the conclusion, and we can check it, that the total benefit is 11, as we have seen in the theoretical video, and we have to take item number 3 and we have to take item number 2, and in this small problem we come to the conclusion, even without this algorithm, that it is the feasible solution. I mean, it is the optimal solution. So this knapsack problem with the dynamic programming implementation is very, very important. You are not going to implement it several times, but the theoretical background is very important. So thanks for watching.